So hello student. So your next video is on based on nodal analysis and mesh analysis. Okay. So now I'll start nodal analysis. Okay. So what is nodal analysis? At first we want to know what is node. What is node? Node means a point where more than two branches are connected. Okay, so what is node? Node is a point where more than two branches are connected. So suppose this is a circuit. Suppose this is a circuit. This is a circuit. Okay. Here I'm seeing that some point, one is A, B, C, D, E, F. So what is the node here? So what I am saying, node, which point? This is a node because more than two branches are connected at this point. Okay, more than two branches, 1, 2, 3. So this is a node, one node, two node, but this is not a node, because only two branches are connected at this point. I think clear what is node. Now I have discussed what is node voltage. Okay, now I have discussed what is node voltage. So node voltage means node voltage. So what is node voltage? The node voltage is the voltage between the node point to ground. Between the node point to ground. Okay. So what is node voltage? The node voltage is from node point to ground voltage. Here the node is A is a node. So from node to ground, this voltage is called node voltage. Node to ground. Okay. That means this also ground. This is fully ground. Fully ground. From this node, the ground is called node voltage. If I am taking this branch, so here one voltage source will be there. So this is not a node voltage. If I am taking this branch, so from this A point to D point, this is called node voltage, and also A point to B point, this is called node voltage. Okay. Now I will find. Now I am applying nodal analysis of a circuit. So at first, taking one example. Okay, at first taking one example. This is a R1, R2, R3. Clear? And this is a V1 and V2. Okay. Now I am finding the node voltage. So what is the meaning of node voltage? If I am finding this point voltage at node voltage means node point to ground voltage. So if I am goes through this branch, here I am seeing that one voltage source will be here. If I am goes through this branch, another voltage source will be connected. But if I am goes through this branch, here I am seeing that one is ground connected. So node voltage means this point to ground voltage. Okay. Okay, now if I am find this point voltage or node voltage, then also we can say that this voltage is also across the R3 resistance. That means R3 across voltage is also called node voltage. Okay, so how to find the node voltage? When I am unable to give any current direction in a circuit, okay, if I am unable to give any current direction in a circuit, then I am applying nodal analysis. I am taking here one simple example. Okay, the question is find the current through the R3 resistance. The question is find the current through the R3 resistance. Okay, here R3 resistance, if I am considering this current is I, if I am considering this current is I, then how to find the node voltage? Then how to find the node voltage? Or through nodal analysis, how to find the current? Through nodal analysis, how to find the current? At first, I am trying to calculate the node voltage or this resistance across voltage. Okay, resistance across voltage. At first, I am trying to calculate. Okay. So when I am applying nodal analysis at a point, then I am consider this voltage is higher voltage. Okay, this is a higher voltage and this is a lower voltage. Always consider this is a higher voltage. So from higher to lower the current will flow. From higher to lower. That means from one point, this is a point, from this point all current are leaving, from this point. Okay, so if this is a I1 and I2, then we can write I1 plus I2 plus I equal to 0, because we know that from KCL, from a particular point incoming current equals to outgoing current. The summation of incoming current equal to outgoing current. But here we see that all current are outgoing. Okay, all current are outgoing. That's why we adding this 1 I1 I2 I, okay, equal to 0. Now I am put the value of I1. So what is the value of I1? If this is a resistance R and this is a and from this resistance the current I will flow. If I am taking the voltage, this is a VA and VB. So what is the current? What is the value of current? Current I equals to VA minus VB by R. From Ohm's law, I equal to V by R, but this resistance have two type of polarity from 2 point. Here the polarity, here the voltage is VA, different type of voltage. Here the voltage is VA, here VB. So I equal to VA minus VB by R. Okay. So I1 equals to, this is a higher polarity, V minus V1 by R1 plus I2. What happened? This is a higher polarity, V minus V2 by R2 plus V minus, here the polarity is what? 0, because this is the ground, V by R3 equal to 0. Okay. Now when I am calculating all these value, then I am get the V. How? Suppose we take the value, this is a 20, this is a 10, 2, 2 and 4. So put the value. With R1, R2, R3. Okay. Put the value. So V I am find V1 is 20, R1 2 plus V minus V2 means 10, R2 2 plus here V by R3 means 4 equal to 0. If I am solving this equation, I am get the value of V 4. So 2V 40, 2V 20, V equal to 0, 5V equal to 40, 60, so V equals to 12 volt. So I am get, I think this portion is not clear. So 5V from this line, 5V minus 60 equal to 0. So V equals to 12. V equal to 12 volt. So this is a node voltage. So node voltage means from node point to ground voltage. So what is the meaning of node voltage? Node point to ground voltage. That means I equal to V by R. Here R means R3 or V means node voltage 12 by 4. The answer is 3 ampere. Okay, I think clear all of you. Again I am repeating the problem. Okay, so what is node? Node is a point where more than two branches are connected. Okay, after that, what is node voltage? Node voltage is a voltage from node point to ground voltage. Node point to ground voltage. Okay, now I am applying nodal analysis. When I am considering the node voltage is V, okay, or let the node voltage is V, this voltage always taking a higher voltage. This is a higher voltage. If this is a higher value, I am assuming that this is a higher value, then the current will leave from this voltage or this point. Current leave this 3 branch. Okay, now I am applying KCL at this node. All are outgoing current, no incoming current. That's why outgoing current sum equal to 0. Okay. After that I am find the value of I1. So what is I1? I1 means higher potential minus lower potential divided by resistance. Same as higher potential minus lower potential divided by resistance. Same, higher potential minus 0. Why 0? Because lower potential value is ground, means 0 by R3. Okay. So this way we find the value of V at this point. So V equal to 12. If the voltage of node voltage is 12, that means this voltage across the R3 resistance. R3 resistance drop V. If I find the voltage of R3, then we can say I equal to V by R3. So V 12, V by 4 means 3. Okay. Okay, this is a nodal analysis. Now I am applying. Now mesh analysis. So what is mesh? What is the maze means a small loop. Okay. So what is maze? So maze analysis. What is the meaning of maze? Maze means a small loop. Maze means a small loop. Okay. So small loop means if I am solving the same problem, using maze analysis, then what happens? Okay. So what is the value? This is a 20 volt, 10 volt, 2 ohm, 2 ohm, and 4 ohm. Okay, so maze means only small one loop. But when I am applying KVL, KCL, then I am taking this loop and this loop, as well as if I want to take the whole loop, this is a current. But maze means only taking a small loop, only taking this small loop only. Okay, if I consider this is as a maze, so this is a wrong. Okay, now first criteria, both current direction are same. That means when I am applying KVL, KCL, the current direction is up to U. One clockwise, one anti-clockwise, no matter, both are clockwise, both are anti-clockwise, whatever. But in maze analysis, one direction applicable. If I am taking in first loop in clockwise, then second loop must be clockwise. Okay, this is the first criteria. Okay, after that I am assume this is a I1 and this is a I2. Here we consider only loop current. Okay, here we consider only loop current. Clear? Here we consider only loop current. So now applying KVL at loop 1. So what is the loop 1? This is the loop 1, this is the loop 2. Now I am applying KVL at loop 1. What happened? So this is a clockwise direction, plus minus, so minus 20 because I am consider always the first polarity, minus 20. Now this resistance value plus or minus, this is a plus because this now this direction is everything for this loop. If I am consider this is a clockwise, that means the current will flow from here to here. Okay, in clockwise here to here, that means plus 2 into I1 plus, this is plus minus, the current will enter this is the plus minus. But in 4 resistance we can see that here I1 and I2 both are flow through the 4 ohm resistance, but one is enter this point and another is enter opposite side. So this is a minus. So that's why I am taking I1 minus I2. Why I am I1 minus I2? Because this current is enter plus position and this current is leave through the minus position. Okay. So from 4 ohm resistance we can see that both I1 I2 are flow. That's why we assume I1 minus I2 equal to 0. So 2I1 plus 4I1 minus 4I2 equal to 20. So 6I1 minus 4I2 equal to 20. Equation 1. Equation 1. Now applying KVL at loop 2. Now applying KVL at loop 2. What happens? If I am applying KVL at loop 2 or mesh 2, so what is the meaning of mesh? Mesh means only a small closed loop. Okay, small closed loop. So KVL, that means 4 into I2 minus I1. In this equation, here we see that I1 minus I2, but in this equation I2 minus I1, because this loop current is positive and this is a negative, I2 minus I1. Now plus 2 into I2 plus 10 equal to 0, because I am coming from this direction, so the first value is positive, that's why it is a positive. So 4I2 minus 4I1, 2I2 equal to minus 10. So 4I2 and 2I2, 6I2 minus 4I1 equal to minus 10. Okay, this is the equation. If I am solving these two equations, so equation 1 multiply with 6 plus equation 2 multiply with 4 and add it. Okay, if I am, so this is a multiply with 6 and this is a multiply with 4. So 36 I1 minus 24 I2 plus 24 I2 minus 16 I1 equal to 120 plus, this is a minus 40. Okay, so 24 I2 are cancelled. This is a 20 I1 equal to 80. So what is the value of I1? 4. The value of I1 is 4. That is, the loop current of I1 is 4. Now I am calculating next I2 from equation 1. So from equation 1, 6 into 4 minus 4 I2 equal to 20. 24 minus 4 I2 equal to 20. So 4 equal to 4I2. 4 equal to 4I2. That means I2 equal to 1. That means, what is the value of current through R4 4 ohm resistance? Same question. 4 ohm resistance, current through 4 ohm resistance, I1 minus I2, that means 4 minus 1, 3. If you are unable to understand the question or problem, then again and again, repeated time, you watch the video, then you understand. Okay, so I think clear all of you. What is the mesh analysis? Mesh analysis, we always assume the mesh current, not a branch current. Okay, we always assume the mesh current. Clear? So, or what is the main point? Both current direction are same. Yeah, the both current direction. If I am assuming the first loop is anti-clockwise, then it is also anti-clockwise. No matter. But I am preferred always clockwise. This is a calculation purpose is more suitable. Okay. So thank you class.